All right, it's possible on the internet you have seen the cool little trick for dividing fractions that when you see the denominator is the same, you could just go straight across and then you can write 8 over 5. You can just kind of ignore these 9s. You could put the 8 on the top, the 5 on the bottom, and then get 8/5, which of course is 1 3/5, but we'll ignore that for right now. And you get that 8/5. The big question is, what? Why does that work? Why? How does that work? And here, teachers, here's the thing. Just exchanging this cool little trick instead of the traditional algorithm is no better, right? This is a trick, and unless it makes sense, we shouldn't teach it. So this video is going to show you why this cool little, the common denominator thing for dividing fractions, why it makes sense. All right, let's start with 6/7 divided by 1/7. So basically, we're going to use what's called the measurement method of division, where we're going to say that 6/7 divided by 1/7 means how many 1/7 fit into 6/7. So there's two kinds of division. One's called partitive, the other's called measurement. We're going to be using the measurement technique right now. So we're going to say how many 1/7 fit into 6/7, all right? Well, that's pretty easy. We could take our 1/7 right here, and we could say once, twice, 3, 4, 5, 6. Oh, look at that. It fits in there 6 times, because we could see it once, twice, 3, 4, 5, 6 times, all right? So there we go. That makes sense, all right? So now let's go here to 6/7 divided by, what do we have now? We have 2/7, right? All right, so here's our 2/7, here's our 6/7. So the big question is, how many 2/7 fit into 6/7? Well, we could take our 2/7 right here and we could say, well, it fits in once, twice, 3 times. Oh, look at that. Once, twice, 3 times. So we know the answer is 3. Now, how do we know that? Well, let's think about it. If this was only a 1/7, all right? So if it was only a 1/7, it would fit in once, twice, 3, 4, 5, 6. It would fit in 6 times. But it's not a 1/7 now, is it? It's actually, let's move this right here. It's actually a 2/7. So instead of it fitting in 6 times, we actually have to divide by 2. Why do we have to divide by 2? Well, we have to divide by 2 because instead of fitting in 6 times, it's twice as large, so it's only going to fit in 3 times. So basically what ended up happening is originally, if it was a 1/7, it would have fit in 6 times, but we have to divide by 2 because this guy is twice as big. It's going to fit in 3 times. 6 divided by 2 is 3. So there's our 6/7 divided by 2/7. So let's continue. So let's do 6/7 divided by, what do you think we're going to do? Word. It's going to be 3/7. So we want to know how many 3/7 fit into 6/7. Well, we can do it by inspection here. Once, twice. So it fits in twice. So we know the answer is 2. Now, how did we get that? Well, remember, if this was a 1/7, it would fit in 6 times. All right? But it's not a 6/7. A 1/7. It's a 3/7. So instead of it fitting in 6 times, like a 1/7, we have to divide by 3 because it's 3 times as large. So what a 1/7 would be right here. There's our 1/7. 1, 2, 3, 4, 5, 6. There's our 6. But it's 3 times as large right here. And so this and this actually group together, and it fits in less times, right? We're going to have to divide by 3 because it's 3 times as large. So 6 divided by 3, over here, 6 divided by 3 is 2. And there's the 2 that we knew the answer was going to be. Now, at this point, we should start to see a pattern, but let's do one last one. So 6/7 divided by, and let's do, of course, 4/7. So let's use logic. Now, if we were to move this, 4/7 fits in once and not a second time. So it doesn't fit in 2 times. It fits in once plus some more. So we're a little confused on the answer, aren't we? So let's use some logic. So the idea would be if, it's not, but if this was a 1/7, what would the answer be? It would be 6. So if it was a 1/7, it would be a 6. But it's a 4/7. It's 4 times larger. So we have to divide by 4 because it's not going to fit as many times. So 4/7 fits into 6/7, 6/4 times, which reduces or simplifies to 3/2, which actually equals 1 and 1/2. And sure enough, we can look at this and we can see, oh, look at that. 4/7 fits in to 6/7. Let's see, 1 time with 2 out of 4 left over. So that's 1. Here's our 1 whole right here. And this represents our 1/2. So there's our 1 and 1/2. Now, at this point, we really need to be seeing a pattern. So if we're not seeing the pattern, let's kind of zoom out. And let's take a look. So what we've got here is we've got 6/7 divided by 1/7 is 6. We've got 6/7 divided by 2/7. That was 6 divided by 2, which equaled 3. And then we had, right over here, 6/7 divided by 3/7. That was 6 divided by 3, which was equal to 2. And then lastly, the last one we just did, 6/7 divided by 4/7 is 6/4, which ended up equaling 1.5. So following this pattern, what are we going to do for 6/7 divided by 5/7? Well, we would do 6 divided by 5, which is equal to 1 and 1/5. Because zooming in a little bit here, zooming in, how do we know that this is true? Well, we know that 1/7 would fit in to 6/7 6 times. But then we have to divide by 5 because it's much larger than 1/7. So 6 divided by 5 gives us 1 and 1/5. But wait, there's more. What if the fractions do not have the same denominator? What are you going to do then, right? What are you going to do? Well, let's use a little bit of logic here, and we're not going to panic yet. And so we're going to say, well, let's first figure out what 2/3 looks like. So 2/3 looks like this. There's 2/3. And then 1/4 is going to look like this. And clearly, we cannot compare these quite yet because the intervals, the pieces are different, right? So we're going to group this together right here. Woohoo! All right, and so first thing we're going to do is, hey, let's get common denominators. So we're going to take each of these thirds and cut them into 4 pieces. And then we're going to cut each of these fourths and cut them into 3 pieces. All right, so let's do that. So each of the thirds is going to be cut into 4 pieces. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So instead of having 2/3, we now have 8/12 divided by, and then we're going to cut those fourths over here. We're going to cut each of the fourths into 3 pieces. And so we're going to get 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And so now we have 3/12. So the big question is 8/12 divided by 3/12 is what this becomes, right? Instead of thinking of it as 2/3 divided by 1/4, it becomes 8/12 divided by 3/12. Well, now we can officially use our nice little idea. Our idea is, let's think about twelfths. And if we were to say 1/12, how many 1/12 would fit into 8/12? We know that that answer would be 8. But we're not talking about 1/12, we're talking about 3/12. So we actually have to divide by 3. So our answer is 8/3, which ends up being 2 and 2/3. Now, how can we see that? How can we prove that? Or how do we see it in our picture? Well, we're actually saying how many 3/12 fit into 8/12. All right, so how many 3/12 fit into 8/12? So let's do yellow. So here's a group of 3/12. Here is a group of 3/12. So we could see 3/12 fits in once and once again. And then we have these two little pieces. So that's 2/3 because we were circling groups of 3/12. We only have 2, so that's 2 out of 3. So there is our 2 and 2/3, which is exactly what we knew.